Some various researches and examples about Dijkstra's shortest path example. In here we can see some of them. After reading some of these, I try to explain it with a simple example. Let's think that we are in Istanbul Bilgi University, Central Campus. Now we are in KD4 building and we have got geometry class in A1 building. We need to go to M1 building. While we were going, we want to buy a cup of coffee from one of these stores, and we need to be hurry. We need to find the shortest way because the lesson is already started. So in here we can see the distances between how much minute it takes from going KD4 to Central Dükkan, for example. It takes. So in this table we can see our vertex, our points. In here we can see the shortest distance from KD4 because the KD4 is our starting point and the previous vertex. So I divide these vertexes, these nodes, these points in two groups. One of is visited and the other one is unvisited. So now we are in KD4. Our first rule is visit the unvisited vertex with the smallest known distance from the start vertex. Our first star vertex. It's itself KD4. So it's 0, and we give other vertexes the infinity value. So after that, our second rule is for the current vertex, examine its unvisited neighborhoods. So our neighbors are one Central Dükkan and the other one is Espresso Lab. It's 0.6, Central Dükkan is 6. I write 6 and the previous vertex is KD4. In here we can see the Espresso Lab 0.11. We update it with one value and write it the KD4. So our third rule is visit the unvisited vertex with the smallest known distance from the start vertex. So Central Dükkan is 6, Espresso Lab is 1. So we came to Espresso Lab. After we came to Espresso Lab, we visit our unvisited neighborhood. So Central Dükkan is our neighborhood and Cafe Nero is our neighborhood. Okay, Central Dükkan is 1.2, it's 3, and Cafe Nero is 1.1, it's 2. In the previous example, we write 6 to Central Dükkan, as we can see here. So we find a shortest way, so we need to update our table. Now we write 3 to our shortest distance, and our previous vertex is Espresso Lab. So we write 1 plus 1, 2 value to Cafe Nero, and our previous vertex is Espresso Lab. Now KD4 and Espresso Lab are visited vertexes. So now we go to where we go from here. We need to go to the shortest vertex. So it's not Central Dükkan is 3, Cafe Nero is 2. We need to go to Cafe Nero. Okay, now we are in Cafe Nero. So let's visit our unvisited neighborhoods. One was a geometry class 1.1.5, it's 7, and the other one is Central Dükkan 1.1.2, it's 4. So we write table, we don't write 4 to this table because 3 is smaller than 4, so we don't need to update with the 4 value, and we write 7 to this geometry class. In here Cafe Nero is our previous vertex. After that, where we can go, we go to the smallest value. So now we go to the Central Dükkan, it's 3. So now we are in Central Dükkan, our unvisited neighborhood. We have got only the geometry class left. It's 1.1.2.5, it's 7, sorry, it's 8. And we don't need to update because we find 7 is smaller than 8. We don't need to update this value. So the last one is lastly we came to our geometry class and we finished all the table like that. So if we look at the shortest way, it's from geometry class to Cafe Nero to Espresso Lab to KD4 1.1.5. It's 7, 5, 6, 7. We find 7 value in here. Okay, let's look at the Python code. In here we can see some Python code about this Dijkstra's shortest path explanation, and here it explains the code. In this part, in the first one it makes the first one 0 and the other vertices infinitive in this part of the code. So in the second part it makes all nodes unvisited. In the third part we create a list that first one was visited and the others are unvisited. And in here the fourth part we change the value before we write if we find a shorter path, that we do in central dükkan, as we remember. In the 5, in here we make a node which we unvisited, which we visit, and lastly we find the shortest path at all. So let's look at Python code. Edit Python script. I copied this code and in here I add my vertex points KD4, Central Dükkan, Espresso Lab, Cafe Nerdo, and our geometry class. And in here I add the distances from KD4 to Central Dükkan 6, KD4 to Espresso Lab 1, blah blah blah, and last Cafe Nerdo to geometry class 5. In here we can write the distances. After that we print the shortest path, and the shortest path, as we can see in here, KD4, Espresso Lab, Cafe Nero, geometry class. As we remember, KD4, Espresso Lab, Cafe Nero, geometry class. Let's look at our example. In here we can see geometry class, before geometry class, Cafe Nero, before Cafe Nero, Espresso Lab, before Espresso Lab, KD4, Espresso Lab, Cafe Nero, geometry class. That can we see in the code the same result, KD4, Espresso Lab, Cafe Nero, and geometry class. Thank you for listening.